Okay, guys, so we've made it to section 4.2, which discusses antiderivatives as area. And so there's two main types of problems that we're going to look at in this specific section. The first one does not involve curves. Okay, so you'll understand what I'm talking about as I go through this problem. The second one does involve curves. And so when it does involve curves, you have to use a process called Riemann sums. So take a look at the second video that I post for this lesson to look at an example like that. Okay, but if we take a look at this first example, so I've given you an indefinite integral, and the indefinite integral is from 2 to 5. So if I take a look and show you how I would say this, I would say we're going to take the integral from 2 to 5 of 1 plus x with respect to x. Okay, and it's going to ask you in these problems to use geometry to find the area under this thing, okay, or to evaluate this integral, okay? And so if we're going to use geometry, we're going to graph this function, okay? So I'm going to draw you a coordinate plane right here. All right, so you've got a coordinate plane, and hopefully if I come over here in side space, you remember that if f of x equals 1 plus x, because that's what we're integrating, that is a linear function. And for those of you that are still struggling, you may want to write it as y equals 1 plus x, because hopefully you realize that your slope is 1 and your y-intercept is also 1. So if I go graph this line, I go up to 1 because my y-intercept is 1. My slope is 1, so I go up 1, over 1, up 1, over 1, up 1, over 1. I keep going up 1 over 1 because of the slope of this particular function. I can also go down. And so I've got this little line. And so I'm going to connect these ordered pairs. And so this is the line that I'm looking at. Okay? And this particular problem wants us to focus on the interval from 2 to 5, guys. That's what that tells us. So if I come down here on my x-axis, I'm going 1, 2, 3, 4, 5, 6. So I'm focusing on 2, 3, 4, 5, 2 to 5, right here. So I'm only looking at this graph from this line to this line. Okay, so I want to find the area of this shape. And if I come up here, here's the shape that I'm looking at. And those of you that remember your stuff from middle school, you realize that's a trapezoid. But most of us don't know the formula for a trapezoid or the area formula for a trapezoid. So what I can do is I can take this shape and break it into two particular shapes. So take a look here. If I draw a line right here, I have now made a square. And we all know the area of a square. Okay, so if I want to focus on this part, find the area of this shape, that area would be base times height, and area would equal your base, which is 1, 2, 3. So your base is 3. Your height is also 1, 2, 3. So the area of that square is 9 units squared. Okay, so we found the area of one piece. And so now let's go find the area of the second piece. So if I find the area of this top shape, well, the top shape is not a square, obviously. The top shape is a triangle. So the area of a triangle is 1/2 base times height, which will be area equals 1/2 of your base. Your base is still 1, 2, 3. And your height, by coincidence, is another 3. And so 3 times 3 again is 9, and half of that is going to be 4.5. So the area of the top piece is 4.5 units squared. So if I want to find the area of the entire figure, then I need to add those two areas together. So if I add the two areas together, I'm going to get 9 plus 4.5. which equals 13.5 units squared, which means the integral from 2 to 5 of 1 plus x with respect to x